The diesel exhaust after-treatment system consists of a diesel oxidation catalyst for NOx control and the diesel particulate filter, or DPF, for particulate control. One of the main purposes of the DPF is to collect particulates from the engine exhaust in order to minimise discharge of soot to the atmosphere. The soot particles accumulate in the channels of the DPF and are burned off at regular intervals through a process called regeneration. This prevents the DPF from clogging. The ECM commands the DPF regeneration after calculating various vehicle conditions such as DPF pressure difference, exhaust gas temperature, engine oil quality, engine speed, and so on. Excessive accumulation of soot in the DPF can cause a drop in engine performance. During regeneration, additional fuel is injected via multiple post-injections in order to increase the exhaust gas temperature. During this period, the DPF temperature is raised to approximately 600 degrees Celsius or 1100 degrees Fahrenheit, and the accumulated soot is oxidised or burned off as CO2. A logged DPF pressure sensor signal voltage high DTC indicates the voltage on the signal circuit has exceeded the expected value for a predetermined time. This could be caused by a short to voltage on the high reference circuit, a short to voltage on the signal circuit, or an open on the low reference circuit. A short to voltage on the high reference circuit will set a DPF pressure sensor signal high DTC. This would be confirmed by a meter reading of over 5.2 volts when connected between battery negative and the high reference terminal in the pressure sensor connector. Turn the ignition off and disconnect the ECM. Turn the ignition on and monitor the meter. If the voltage disappeared, then the short is in the ECM or a circuit from the ECM. To isolate the short, perform a continuity test between the pressure sensor high reference terminal and every other terminal in the ECM connector. If this is okay, then the short to voltage must be in the ECM. If after disconnecting the ECM connector, the voltage did not disappear, then the short is in the harness between the two connectors. With the meter connected between the low reference terminal in the pressure sensor harness connector and battery positive, and the ignition on, you should see battery voltage displayed. A meter reading of 0 volts may indicate an open. Move the meter lead and back probe the ECM low reference terminal and monitor the display. If battery voltage is now observed, then the open is between the two connectors. If there is still no reading on the meter, then switch the ignition off and disconnect the ECM connector. Check for terminal tension and corrosion on the affected terminal. If there is no problem here, then the fault will be an open in the ECM. With the DPF pressure sensor disconnected and the ignition on, connect the meter between battery negative and the signal terminal in the DPF sensor harness connector. You should see 0 volts. If there is any voltage displayed, then there is a short to voltage in the circuit. Turn the ignition off and disconnect the ECM. Turn the ignition on and monitor the meter. If the voltage disappeared, then the short is in the ECM or a circuit from the ECM. To isolate the short, perform a continuity test between the pressure sensor high reference terminal and every other terminal in the ECM connector. If this is okay, then the short to voltage must be in the ECM. If after disconnecting the ECM connector, the voltage did not disappear, then the short is in the harness between the two connectors. If the low reference, high reference and signal circuits test okay, then the fault can only be in the DPF pressure sensor. As technicians, we try to perform tests and checks in an order that is efficient and accurate. Consistent training is the key to effective diagnosis. Thanks for watching.